Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the planes. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we are required to evaluate the projections of the oblique plane which happens to be inclined to both the horizontal plane as well as the vertical plane. So here we have got a rectangular lamina ABCD which is having the dimensions measuring 30 millimeter by 20 millimeter. The surface of the lamina, it is inclined at an angle of 30 degree with respect to the horizontal plane. So since the first inclination of this rectangular lamina happens to be with respect to the horizontal plane, so to begin with, we are going to assume that this rectangular lamina happens to be parallel to the horizontal plane to begin with. And since this rectangular lamina in the first instance it will be parallel to or it will be resting onto the horizontal plane, so the true shape projections of this rectangular lamina will be drawn onto the horizontal plane, and these rectangular true length projections of the lamina will be drawn below the XY reference line. Now we are also provided with the information that the shorter side of this particular lamina, that is side AB, it is resting onto the horizontal plane. Now since after the inclination of this rectangular lamina surface with respect to the horizontal plane, it is resting onto the shorter side. So please check, if we are going to draw the orientation of this rectangular lamina below the XY reference line into this orientation, then if we try to lift or incline this particular lamina with respect to HP at an angle of 30 degree, then it will be either resting upon this particular edge, or if I lift it like this, then it will be resting on the horizontal plane on this particular edge of the rectangular lamina, which happens to be the longer edge. So either I have to tilt it like this or I have to tilt this lamina like this. So either way around, the lamina will be resting onto the ground onto the longer edge. So which is not going to satisfy this condition that it is going to rest onto the horizontal plane on the shorter side of this particular lamina. So if we place the lamina below the XY reference line into this orientation, so then we will find that if we are going to incline this lamina either this way or this way, then the lamina will be resting onto the ground onto its shorter edge over there, right? So either it will be resting on this edge or it will be resting on the ground on this edge. So this is the correct orientation of the true shape of the lamina which needs to be drawn below the XY reference line. And then we have been provided with the information that this edge of the lamina, so this edge is further inclined with respect to the vertical plane at an angle of 45 degree. So this becomes an oblique rectangular lamina which happens to be inclined to the horizontal plane first, and then it is inclined with respect to the vertical plane. So corresponding to this oblique rectangular lamina, we are required to draw the projections of this particular lamina. So let us proceed with the construction of the orthographic projections of this oblique lamina which happens to be inclined to both horizontal plane as well as the vertical plane. So as we have discussed that this lamina, it is inclined to the horizontal plane to begin with. So to begin with, we have to assume that this rectangular lamina happens to be parallel to or it is resting onto the ground. So since one of the edge, that is shorter edge, it is resting onto the ground, so we have to assume that this rectangular lamina happens to lie onto the ground. So onto the ground means that in the top view, we are going to obtain the true shape projections of this particular lamina. Here we have drawn the rectangular lamina ABCD. So this represents the top view true shape projections of this particular lamina, and the shorter edge AB and CD over here, so they will be represented as 20 millimeter, and the longer edge BC and AD will be represented as 30 millimeter. So having drawn the true shape projections onto the horizontal plane, now we will proceed with the construction of the front view projections of this particular lamina. And since this lamina happens to rest onto the ground or onto the horizontal plane, so the front view projections of this lamina will reveal the edge view or the line view of this particular lamina which is resting onto the horizontal plane. Now, if we are going to look at this lamina from this side, so we are going to observe that B dash and A dash points, they are going to coincide with each other. And once we draw the projection line through the points C and D of the top plane, so we will find that C dash and D dash points, they will also be available onto the ground. So B dash, A dash points, they are available onto the horizontal plane or the XY reference line. Similarly, C dash, D dash points, they are also available onto the ground or onto the horizontal plane. So having obtained the front view projections corresponding to B dash, A dash and C dash, D dash, now once we join B dash, A dash and C dash, D dash, so we are going to obtain the edge view projections in the front view over here. Now we have got the information that the surface of the lamina is inclined at an angle of 30 degree with respect to the horizontal plane. So we know the length of the front view projection which happened to be 30 millimeter. Now this 30 millimeter length of the front view projection, this we have to incline into this orientation. Why in this orientation? Because we know that the rectangular lamina is resting onto the ground with respect to its shorter edge. So this is the shorter edge over here, right? Otherwise, if this edge was not provided to us as AB, we could have tilted it like this also. So again, it would be resting on the shorter edge onto the ground. Now, since the name of the shorter edge has been provided to us, so it should be resting onto the edge AB. So this way we are required to incline the surface of the lamina at an angle of 30 degree with respect to the ground or with respect to the XY reference line. So we have marked this angle of inclination theta. It is equal to 30 degree. Why we have marked this angle theta? Because this is the true length of the surface of the lamina. That is, this is the true length of the edge BC over here. Since we have marked this edge length is equal to 30 millimeter, now I can mark the points B1 dash and A1 dash over here, and at a distance of 30 millimeter, which is equal to the front view projection which we have obtained earlier, right? So this front view B dash, A dash, C dash, D dash has been transferred at an angle of 30 degree over here. Now, once we have obtained this edge view inclined at an angle of 30 degree, now we have to obtain the projections of this lamina in the top view. So for that purpose, we have to draw the vertical projectors through B1 dash and A1 dash. Similarly, vertical projectors through C1 dash and D1 dash have been drawn. Now, in order to obtain the corresponding points into this top view projections over here, the horizontal projector lines will be drawn through the points A, D in the top view from the previous construction, and similarly, the horizontal projector line will be drawn through the points B and C, which are the plan projection points which we have drawn earlier. Now let us find out the corresponding points. So the intersection of the vertical projector through A1 dash and A over here, so this will provide us with the point A1. Similarly, the vertical projector through B1 dash, wherever it intersects with the horizontal projector through the point B, so we are going to obtain point B1 over here. Similarly, we have got vertical projector from the point C1 dash, and wherever it is going to intersect with the horizontal projector drawn through the plan projection point C, so the intersection of these two projection lines will provide us with the point C1 in the plan projection over here. Similarly, you have got the vertical projector line drawn through the point D1 dash, wherever it intersects with the horizontal projector line drawn through the point D. So we obtain the point D1 over here. So once we have obtained A1, B1, C1 and D1 points in the plan projection view, now we are going to join A1, B1, C1 and D1, right? So once we join this, so we observe that this length A1, B1 happens to be the true length, whereas the edge B1, C1 is represented as an apparent view projection of the edge B1 dash, C1 dash, which was appearing as a true length in the front view. Now the reason for this reduction in the length of the edge B1, C1 and A1, D1 is that because these edges, they happen to be inclined at an angle of 30 degree with respect to the horizontal plane. So that is why we have seen the foreshortening or the reduction of these two edges in the top view projection. Now having drawn the top view projection corresponding to the inclined surface of this particular lamina, which happens to be inclined with respect to the horizontal plane at an angle of 30 degree. Now we also know that the edge onto which it is resting onto the ground, that is AB edge over here. So this AB edge is the one which is lying onto the ground. So this is the edge B1 dash, A1 dash in the elevation. So this is the edge A1, B1 which is appearing to us as a true length in the top view projection. Now this edge, it is further inclined at an angle of 45 degree with respect to the vertical plane. So now we have to mark an inclination of 45 degree with respect to the vertical plane in this view. And now we are required to transfer this rectangular plan projection at an angle of 45 degree with respect to the vertical plane such that the edge onto which our lamina is resting onto the ground, so this edge should be placed with respect to this orientation line which we have drawn at an angle of phi is equal to 45. Why we have marked this angle phi? Because onto this particular orientation line, the true length in the plan has to be located into the third projection that we are required to draw. So this rectangular plan projection will be shifted over here in such a way that A1, B1 edge should be lying at an inclination of 45 degree with respect to the vertical plane. So here we have to mark this edge as A2, B2 over here. So please check, we have marked this A2, B2 and we have marked this true length over here. And this was the apparent length. So we will measure the apparent length from this point and this point, and we will be drawing two perpendicular lines over here in order to be able to transfer this particular figure into this view over here. So now we can mark this A1, B1 30 millimeter. So this will be marked as A2, B2 is equal to 30 millimeter. We will measure the length B1, C1 over here and draw perpendicular from this point. Mark this length is equal to B2, C2. Similarly, from A1 we will measure this length A1, D1 and same length will be transferred over here, right? And then join C2 with D2. So this way we have been able to transfer this figure into this orientation in which the shorter edge onto which the lamina is resting onto the ground, it is tilted or it is inclined at an angle of 45 degree with respect to the vertical plane. Now having obtained this final plan projection view, now we are required to draw the corresponding view in the front view projection. So once again, the corresponding points between the vertical projectors drawn through the points A2, B2, C2, D2 and the horizontal projection lines which we are going to draw from B1 dash, A1 dash and C1 dash and D1 dash will be observed over here. So let us start with this. From A2 we are going to draw a vertical projector line in the upward direction. So wherever this vertical projector it intersects with the horizontal projector drawn through the point A1 dash from the previous elevation projection view, so this intersection will provide us with the point A2 dash. Similarly, from B2 point of the plan projection, again we are going to draw a vertical projector in the upward direction. So wherever this vertical projector will intersect with the horizontal projector which has been drawn through the point B1 dash over here, so we are going to obtain the point B2 dash. Now let us draw the vertical projector through the point C2. So now once we are drawing vertical projector through the point C2, so wherever it intersects with the horizontal projector line which is drawn through the point C1 dash, so this point of intersection will provide us with the location of the point C2 dash. And finally, we are going to draw the vertical projector upwards from the point D2 and extend this vertical projector till it intersects with the horizontal projector drawn through the point D1 dash from the previous elevation projection view. So now A2 dash, B2 dash, C2 dash and D2 dash points, they have been obtained in the front view projection corresponding to the top view which we had obtained earlier. Now having obtained A2 dash, B2 dash, C2 dash and D2 dash, now we can join all of these 4 points, and this is the final front view projection of the oblique lamina which happens to rest onto the ground, onto its shorter edge AB, and this shorter edge is further inclined with respect to the vertical plane at an angle of 45 degree. So this way we have learnt about the procedure to evaluate the front view and top view projections of an oblique rectangular lamina ABCD which happens to be inclined to both the horizontal plane and the vertical plane. So this is all for today. So I hope that through this discussion you would have understood about the procedure to evaluate the orthographic projections of the rectangular lamina which is inclined to both the horizontal plane and the vertical plane. So we are going to continue with further discussion regarding few more illustrative cases of the projections of the planes in the coming lectures. So thank you very much. Thanks a lot.